Hello everyone. So I'll just wait for 5 more minutes so that everybody can join and then we can start. Okay. Meanwhile, if anybody has any questions, they can ask. Uh, yes, Ruby, what I'll do, I'll briefly recap whatever we have done, and there is also recording and the PPT available for the previous sessions, so you can just go through that. Okay, but I will briefly recap, so no need to worry. Okay. So I'm not audible, so I'll just tell you where you can get the recordings. So you have to go to the Swayam portal of Geographic Information System, and okay. So once you come to this page, and if you scroll down here, you can see problem solving session July 2026, and there we have an option of problem solving session recording. Okay, so you can click here and you can see this Excel sheet. So here I have uploaded the YouTube link, and here I have also uploaded the PPTs of the previous sessions. So you can get these from here. Okay, so is this okay? And now is my voice clear? Anyone? Okay, so we'll start. So I'll just briefly recap whatever we have done. The like the name of this course is Geographic Information System. So what is Geographic Information System? So it is basically a tool that through which what we can do is that it is basically converting this real world, which has very complex features, into GIS world. GIS world is having like different layers of this real world that are kind of simplified version of what is there in the real world. So, for example, if we are interested in like floodplains or what is the land use land cover types, then what we will do, we'll only look at the land use land cover types in the real world and try to map it in the GIS world. So, what we do is that we accept large volumes of spatial data, and they can be derived from different sources, like you can go to the field and get the data. You can also get satellite images using remote sensing techniques. So from variety of methods you can get the data, and then what you do, as per your requirement, you make a layer so that you are easily able to identify different kinds of patterns that are there in the real world. And like in this GIS world, we have like different layers of the real world. As per our specification, we make the layer. Okay. So now, um, how how we represent it. So basically, uh, the real world model is given, and these models are basically simplified representation or human understanding of geographic phenomena using simplified data model. Okay, and there are different types or entities in the real world model. So there can be type, means classification of the phenomena like road or lake. There can be different attributes, like for lake it is going to be area, for road lake it is going to be depth, for road it is going to be what is the length of the road, and for like there are like for a city there can be one attribute which can be what is the population of the city. So attribute is basically the characteristics of what entity we are looking at. And then there is relationship, which is kind of which define the connections between two different entities. Okay, so this is called as relationships. Now, there are different types through which we can collect the data. So, primary collection means we are collecting the data or generating the data. So, it can be through GPS or surveys, or through remote sensing, we are getting the satellite data. And then there is secondary data source, in which what we are doing is that we are taking existing databases, reports and maps, and then deriving the information out of those existing maps or database or reports. Okay, so those data collection method is called as secondary data collection method or secondary data sources. Okay, and there can be different types of sampling methods. So how you are sampling the uh, because you cannot sample each and every uh, at each and every place, then what you do, you can use different kinds of method. So first method is random method, so in which you like all the locations have equal chances, and you are randomly going to any location and then sampling that. Okay, so this is kind of unbiased and unbiased method, and it is kind of scattered. Then we also have systematic um, sampling method, so in which at every regular interval or at equal spacing we take the samples. Okay, and then we have stratified sampling method. So in this type of method, what we do is that suppose we have like different zones, like there is some lake area, there is some forest area, or like different flowers or garden area. So what we require is that we need to represent all three different zones, right? So we need to have samples from all three zones. So in this stratified method, we divide the area into different zones, and from each zones or subpopulations, we are going to sample. Okay, so this is the third type of sampling method that we have. Now, how the relationships can be derived? So they can be derived from coordinates like intersection, or from structure. So suppose a feature starts from somewhere or ends somewhere. So from that structure, the relationship can be derived, and then as attributes. Okay. So these are the three types through which the relationship can be derived. Okay. However, when we look at the data, there can be some errors associated with the data that we have. Okay, so we need to sometimes we need to have some data quality checks. So there are different compromises that can happen in the data quality. First is the positional accuracy. So positional accuracy means the coordinate systems or the coordinates that are assigned to the image is not correct. So we need to correct the geographic location or positional. We need to increase the positional accuracy. Okay. Second can be attribute accuracy. So sometimes the data values can be wrong. So for that we need to check the attribute accuracy. Third is temporal accuracy. So, like you need to validate the data over time. So, suppose after some times the uh, the properties, or in the real world the uh, like suppose you are looking at population or something else, like a lake area, and over the time it can change. Okay, so if you are looking at data that is like very old, that is not going to be accurate for the current period. Okay, so you need to also check for the temporal accuracy, if that data is valid right now or not. Then there is logical consistency. So sometimes there can be inconsistency in the structure of the data. So that checks we need to do. And data completeness, that is also a data quality dimension. Okay. So these are some data quality checks that we need to do. And in the last class, what we were doing is that we were looking at georeferencing and digitizing. So for the positional accuracy, georeferencing is done. So georeferencing is basically a process of assigning coordinates to a map. Okay, so for this we were using QGIS, and I'll try to use ArcGIS also, so that people who are using ArcGIS can also know. Okay, so let's start. So, is anybody like trying to do any georeferencing or using any QGIS or ArcGIS steps that we have done previously? So, let's see. This is a slide for georeferencing in QGIS, and this is for ArcGIS. So maybe I can start with the ArcGIS step. Okay, so how can you do georeferencing? So these are the steps, and I also have added pictures here, so you can do it now. So actually that ArcGIS is in another laptop. So I'll share my screen from that laptop. So now if you look here, this is ArcMap. So this is ArcGIS. So people who are using ArcGIS can open their ArcGIS app, ArcMap, and you can see this is the interface of the ArcMap. So here we have the layers. Whatever layer you add is going to appear here, and here from here you can search for tools or other things, and you can also look at the catalog. So now you can see here we have a toolbox which is georeferencing. Okay, so this particular toolbox sometimes will not appear if you open your ArcMap. Okay, so what you have to do, you have to just go here and right click. So go in the like main menu area and then right click, then you will see the list, and from here if you see where is georeferencing, you can see here if you select this georeferencing will appear. Okay, so now for georeferencing we need to have any image, right? So, so first of all, we will add data. So for adding data, you have to go to File and then come here, Add Data, and then you can add data from here. Okay, so if you remember, while we were adding data in QGIS, what was happening? We need to know like whether the data is raster data or vector data, and then you can select a raster data or vector data. But here you don't need to know if you are adding a raster data or vector data. You just have to go to add data. You can add any raster data also, shapefile also, like all data types you can add from here. Okay, so go. So if you don't know where the folder is, you can go here and connect to the folder. So So now I have connected to that folder. Now you can see, I can see these images, JPG files, and then I can add it. Okay, so why there was a warning appearing? Because again, this is not a georeferenced um, file. It is a JPG file. So that is why it was showing that it is going to appear anywhere in your map because it doesn't have any coordinates. So in georeferencing, what we have to do, we have to assign the coordinates. Now you can zoom the layer, and then we know the coordinates because we have grids in the map. Okay, so now if you see here, from here you can select which file you want to georeference. Okay, so right now we only have this one particular layer or JPG file in the layers, right? So we can only georeference this particular layer, okay? Now what we will do, we'll fit to display and then so what we'll do, we'll we can add control points. Okay, so there the option was add GCP, which is add ground control point. Here the option is add or select control points. Okay, so if you select this and you need to be as precise as you can. Okay, now you can input X and Y if you right click. Okay, so now enter the coordinates. So what will be the X coordinate? Latitude or longitude? Anyone? What will be the X value? Latitude value or the longitude value? Okay. Shweta is saying latitude. What about others? X is this, Y is going to be this. Latitude values are these ones, north and south, and these are what? Longitude values. So X is going to be longitude, right? Or latitude. So let's see. So here we have 180 east. So it will be 180 and this is going to be 60. Now here what will we have? Will be 180 and this is going to be minus 40. Now if we come here, minus 40 and this will be also minus 40. Minus 40 and this will be 60. Okay, so now you can see we have like at least 4 points in the map that we have given as control points. And now you can also see the link table and here you can find the residual values. Okay, so like when we were doing georeferencing in QGIS, then this residual value was uh, like easy to find, like it was coming out like to be somewhere here, right at the bottom. So while we were doing the uh, like adding the control points, we were looking at the residual values. But here, if you have to look at the RMS error, then you have to go to the link table. Okay, so you can go to the link table from here. Okay. Now for updating, we need to do this. Update georeferencing. Okay. And it's done. Okay. So now you don't know if like this is done correctly or not. So what we'll do, we'll add a shapefile and see if that is coming out to be. So now you can see when I added the India boundary, it is coming roughly at the location of India, right? So that means this is georeferenced. Okay. So this is how you can do georeferencing. Now I'll show you there is another way also which you can apply to do georeferencing. Okay. So suppose actually this map is not very accurate. Okay. So but you can also like while doing georeferencing what you can do, you can also rotate, shift and scale the uh, map manually. Okay, so suppose I select shift and now what I can do, can roughly shift this, so you can see the difference, right? I can manually shift this. So if this map is like, maybe I can add another map and then show you. So let us save this one. Okay. Now let me add another map. Maybe this one. Okay, so you can see we are getting this notification that this particular map is having missing spatial reference information. That means it is not, it will not be aligned to the correct geographic location, right? So that is why we need to do georeferencing. So once I add this and zoom into the layer, you can see this is appearing somewhere here, and our actual our actual location for India map to be aligned is somewhere here. So what we need to do, we need to align these two. Okay. So now what we can do, we need to first of all change this fit to display. So once you do that, uh, now we will uh, georeference this particular page. Okay. Now instead of adding control points, now what I'll do, I'll use this manual shifting and scaling. So first of all, we need to scale this because this map is very large compared to the correct geographic locations, right? So, so now you can see I'm scaling this such that it's small. Now I have to shift this. So I'll shift this particular location to go somewhere here, and then I can go here and zoom to the layer. Okay, So now again we need to scale this and then shift. So now this is very close to what we need. Okay, but it is not exactly on the map. Like it is not exactly aligned to the spatial or shapefile that we have for India boundary. So there is another thing that you can do. You can, first of all, I'll zoom in, okay? And then what you can do, instead of adding control points, we can add like the location where we want to move this, okay? So, so suppose this particular point, we definitely know this is this point on the boundary shapefile, right? So we'll select first the location on our map that we need to georeference, and then we'll move it to this. Okay. So now you can see these two are now kind of aligned. Then you can move to other points also. So first on the map and then to the shapefile. Okay. So this is kind of fitting using a shapefile. Okay. So these are different methods through which you can kind of align your map. Okay. So one can be here, then you can also align these points. So sometimes the map that you get is kind of rotated or scaled. So through these methods you can try to align your map with the shapefile. Okay. And then you need to update the georeferencing and then this. So now you can see this is aligned with this and this is on the map, okay, on the world map at the correct location. Okay, so till now, if you have any doubts, you can ask me. Anyone? Any doubts? No doubts? Okay, so till now, stop presenting from this laptop. So one question, when we are doing shift or selecting, we are using mouse, right? Not any keyboard buttons. Yes, we are using mouse only. Keyboard buttons can't be used while we are doing that, okay? So I hope this is clear and it will get more clear once you try to do it, okay? So you should download QGIS or ArcGIS and then try doing these steps Okay, so anybody using any software, QGIS or ArcGIS, like for any other work also? No. I remember somebody was using ArcGIS and like maybe he was asking whether ArcGIS was better or QGIS. Anybody? Nobody is using. So like it will be good if you download QGIS and try to do these small steps, because then you can get confident and you can also like do some projects uh, using these software. So these are very like the applications of this GIS field is very wide, like also in defense, also in mineral resources, also in climate change. So lots of things, like people from various fields use these techniques. Okay, QGIS and ArcGIS. So if you want to really learn uh, things from this course and these sessions, I will encourage you to download QGIS or ArcGIS and do like these steps. Okay, and if you have any doubts while doing any of the steps, you can ask me. Okay, so we can go through the steps in the class also. Okay, so georeferencing in QGIS, and then we have georeferencing in ArcGIS. So now we will move on to the next part. Now uh, also, like georeferencing is there, and now you know what is georeferencing. This is basically aligning map with the geographic locations. There is another thing which is called as digitizing. So digitizing is a process where we convert like a feature from a image or map into a vector data. Okay, and we do that by manually tracing this. So what I will do, I'll show you how can you digitize a map and create vector files like point files, line vector files, or polygon vector files from a map. Okay, so first of all, what I'll do, I'll add a map. So now this is the map. First thing is that we need to georeference this. So let me quickly, because last time when we were doing georeferencing, there was some issue that the TIFF file was not getting saved. So we'll see what was the issue. Mm, Also add a boundary map. So now We'll go to the georeferencer. So for that we need to go to layer and then georeferencer. Okay. So now you can see we have this map here, and but this is not georeference. So what are the different ways through which we can georeference this? So first of all, you know these locations, Lothal, Harappa, Mehergarh. So these are some Indus Valley civilization sites. Okay, so these sites right now we know where are they located. So one thing that we can do is that we can um, just click on this Lothal and add lat long values of this particular location. So can anybody tell what is the latitude and longitude of Lothal? Lothal site. So it is what? 72.24 east and 22.54. Okay. Now we have Harappa. So we'll search for so this is 72.8667 and this is 30.6333. Now we have Mehergarh. 67.598, 29.40, and now this 68.14, 27.32. Okay. There is another way through which we can add control points. Okay. So suppose this is the point. You know this point very clearly. Okay. From the feature, and then you can map from canvas also. Okay, so if I go to map from canvas and I can select a point which is the correct location, right? So now those two are linked. Okay, so now you can see these two are linked. So there is this method also that is there for QGIS. Okay, so now what we have to do, we have 5 points. Residual pixels are not that good, But for this class, like when you are doing this georeferencing, you should be as precise as you can. Okay, and then what you have to do, you have to start georeferencing, select output file name. So you can select maybe linear station map. Okay, then okay, and we have to wait for some time. Okay, so now this is successful. Sometimes it takes some time, so we have to wait and to start. So now, if you move this down, you can see this is perfectly aligning with our boundary shape file. Okay, so now you know this particular image is georeferenced, right? And you can see here we have question mark because this layer is not georeferenced. So we will remove this layer so that we are not confused. Now what we will do, uh, you know what is digitizing? Digitizing is there is a map, and what we are doing, we are tracing this map to get a vector shape file or a vector layer. Okay, so if you go through this uh, definition, digitizing is the process of converting geographic features from an image or a map into vector data, okay, by manually tracing them. Okay, so what we have to do, we have to make a shape file here. Okay, so so what I'll do all the steps of manually tracing and making shape files in ArcGIS first, and then we can come back to QGIS. Okay, so I'll stop sharing here. So if you have ArcGIS, what you can do, you can use ArcGIS only, and you don't need to learn QGIS because both of them can do, like ArcGIS can do all the functions that QGIS can do, and I will be telling all the steps in both um, software, using both softwares. Okay, so you don't need to worry. So suppose this is the map, and then we need to make a map with all these cities. Okay, so for doing that in ArcGIS, we need to make a shapefile. Okay, so what you can do, you can just go to catalog. Okay, and then you can select any folder where you want to make the shapefile, and then right click and then go to new. Okay, so go to new, and then you can see shapefile, new shapefile. So you can just click. So right now what we are interested in, We want to make a point shape file, right? A point shape file. So feature type will be point. If you want to make a line shape file, polyline, polygon. Okay, so right now we are interested in point shape file. You can name the file settings maybe and then click OK. So now you can see in the layer we have a shapefile, but there is no feature associated with this shapefile. Okay, so we need to edit this particular shapefile. Okay, so for that you need editor tool. Okay, so suppose if you don't have editor tool, what will you do? You'll just come here in the main menu and then right click and then add editor toolbox. So right now we have this editor toolbox. We go and start editing. Now it will ask which particular file you want to edit. Okay, so we'll select the cities shapefile and then click OK. Now now you can see here all these options are now coming. So we can create features also. If you click on this particular icon, you can create features and then you select this city and then point and you can select these cities. So let me check what is open. Okay, so we'll start again. There was some problem. So first of all, we need to go to editing, then start editing. Then you can go to cities, click OK. Okay, so it is adding all the points, but we are not able to see because of this layer. So I'll just, so suppose these are the cities we are interested in. So you can see these points are added. Okay, but since I was not able to see because of this black feature. Okay, so after you have added the cities, you can stop editing and you can save the edits and then it's done. Okay, so now your city shape file is having these cities that we manually traced from this map. Okay, so that is why uh, this georeferencing step is very important, because if the map is not aligned correctly with the correct spatial coordinates, then whatever like these cities, because you are manually tracing the map, your error in that map is going to come into the error of these vector files also. Okay, so it is very important that you do the georeferencing step very correctly. Okay, so this is how you can add a point shapefile. Now, if you are interested in making a line shapefile, then all the steps are pretty much same. So suppose you have to go to catalog and then right click in the folder and then shapefile. Then instead of point, say polyline, and suppose we are interested in some river, then click OK. Okay, so it's already exists. So now you can see we have added a shapefile which is line, but there is no feature associated with this. So we'll edit this, start editing, then click on river, and then go to create properties, select on river, then line, and then you can trace any river of your interest. So you can see this is the Indus River. So you can manually trace it. So you need to do it as precisely as you can. Okay, and then right click and finish sketch. So now it's done, and then you can save edits and stop editing. Okay, so now this river shapefile is also there. Okay, and similarly you can make a polygon shapefile too if you just have to manually trace the area. Okay, so this is what digitizing step is. Okay, so now you know what is the difference between georeferencing and digitizing and how you can do this in ArcGIS. Now I'll try to do this in QGIS also so that you know what are the steps in QGIS also. Okay, so in QGIS, I'll start sharing my screen. So can anyone tell if my screen is visible or not? Okay, so it's visible. So in QGIS, what we will do, we will trace river network, one of them, and we can trace the archaeological um, civilization sites. So you can see these Harappa civilization, Mohenjo-daro, Lothal, Mehergarh. So these are some archaeological sites that are there, and we can also trace them. And which kind of shapefile we can make out of it? Can anyone tell? Which shapefile will be made if we trace the settlements site? Vector, but what kind of vector? Point, line, polygon? Yes. So this is what I was asking. So if you trace the settlements, what you can make? You can make a point shape file. And if you are interested in the whole area, so this is the area of the Indus Valley civilization. Okay, so if you want to trace this, what kind of shapefile you will get? Anyone? Polygon, yeah. So correct. We will get a polygon shapefile. Okay. So what we'll do, we can make a polygon shapefile in QGIS also. So first of all, to make a shapefile, what we have to do, we have to go to layer and then create layer, and then you can see new shapefile layer. Okay, just select this. You have to give name. So we'll give it of name Indus civilization area. Okay, and we will make it a polygon shapefile. Okay, okay, okay. So now you can see we have this in layer, polygon layer, but there is no feature associated with this. Okay, so what we have to do, we have to go here and then toggle editing. Okay, so and now you can see we can add the polygon feature using this particular um, icon. Okay, so we'll select this and we can roughly follow this curve. So now if you see here, you can see a sign of pencil here. That means this particular shapefile is getting edited. Okay, so now we are manually tracing this. But while you are doing it, and if you need a precise area shapefile, you should always zoom in and do these steps. Okay, so that the errors are minimal. Okay, so whenever you are digitizing, there are going to be some errors, but you want those errors to be minimum, right? So do it very precisely. Okay, so let's see. So this is the civilization area, and we have manually traced it. Now right click. You have to provide ID, so you can give it one, and now you can see this is there. Now you can save this and stop editing. So now this pencil icon is not there. That means the editing is not being done. Okay, and you can also change color use after going to properties and then symbology. And now you can see we have an approximate area of Indus Valley civilization. Okay, so similarly you can also do make a point shapefile and line shapefile. So all the steps are same, but while adding the new shapefile, so suppose we're going to the layer and then go to create layer and then new shapefile layer. Here in the geometry type, you have to define if you want point polygon, or if you want line polygon, or you want sorry, line, not line polygon, line shapefile or point shapefile. So you have to define it somewhere here. Okay. Okay. And you can add point feature. Mm, so every point is assigned one ID. You can also name, like instead of writing 1, 2, you can write Harappa, Mehergarh, Lothal. So whatever ID you are providing, you can just name it. Okay, and then you can save it. So now we also have this settlements. Okay, so this is how you digitize. Digitizing is manually tracing, and we are creating, what is the output? We are getting a vector file out of it. Okay, so your map should be geometrically correct. So all the coordinates should be correct in your map. So your georeferencing step should be as precise as it can be. Okay, so I hope this is clear, everyone. So now maybe we can take a 5 minute break, and meanwhile, if anybody has any questions, any doubts, they can just post in the chat box. Okay. So any questions, anyone? So if not, I have some questions. So the question is, digitizing a river on GIS software will most likely produce what? Point feature, B line feature. Yeah. So everybody is correct. So it's a line feature. Okay. Now, if we zoom out on a map and roads disappear, it's an example of what? Sampling, generalization, digitization, or spatial resolution. Okay, so it is generalization. So what happens when you use any map on your phone or anywhere, when you zoom out a feature, because like you don't want a messy map, some features disappear. Okay, so that is called as generalization. So it is basically simplifying complex feature. So like it will show building as a point. Sometimes if you zoom out a lot, it will not show the building at all, because like it thinks that at that scale that particular building is not like not significant. Okay, so that is called as generalization. Now there is some object relation and GIS map limitation. So what are the limitation of traditional um, GIS model? So for entities or field, the model assume clear boundaries. Okay, and sometimes in the real world, there is not a clear boundary. Also, overlapping phenomena requires multiple layers, and uncertainty exists if we look at the continuous phenomena. Okay, so like if you are looking at some phenomena like temperature or soil, so there is going to be some uncertainty associated with it, because in the real world that particular phenomena is very continuous, but in the raster image we have some area and we are looking at the area average. Okay, so there is going to be some uncertainty associated with it. Okay, so and also we know what is generalization. It is basically simplification of uh, reality for communication and modeling. Okay, now maps are not data model, they are basically only representation. And for creating data models, we are using or deriving information from maps sometimes. So for example, when we are digitizing, we are using map as data source, and then we are deriving some data points from that. Okay, so which of the following is not metadata? So metadata was something that I covered in the first class, and metadata is basically information about the data. Okay, so what is not a metadata? First is A is file creation date, B is coordinate system, C is land use type, and D is source of data set. Okay, so let's see. Some people are saying C, somebody said B. So metadata is basically information about the data. Okay, so it is not going into specifics of the data, it is only the information about the data. So all this source information, coordinate system information, date and projection, these all are metadata. But land use type is something like that can be a part of the data. It will not be metadata. Okay, so this land use type is not metadata. Now there are some digitizing errors. So if you remember, while I was digitizing a polygon file or a polygon shape file or a vector shape file, there can be some errors that can be get introduced. Okay, so what those errors can be? So there those are called as digitizing errors. Okay, and these are different types of digitizing errors. If you see here, these are all different types of digitizing errors. There is one called as undershoots. So when you want to reach this point, so always you have to, while you are digitizing, you should zoom in and see where your point is going. So if you don't do that, sometimes these errors can get introduced. So you can your line was like intended to, your point was intended to go here, and you basically the line is not reaching the intended point and it is going somewhere else. So this is called as undershoot. Overshoot is, it is extending past the point. Okay, then dangle is unconnected line. Then we also have some knots, we can also form knots, then switchbacks, loops. So these are different types of digitizing errors that you can introduce, and it requires post processing or correction. Okay, so sometimes, suppose this is our point civilization area is this one, right? Suppose this is our civilization area, and sometimes what you need to do, you need to correct these points. So you need to rearrange these points, okay? So for that also you can go here and then you can, so I think this is doing for settlement area, okay? So we don't need that. And now what you can do, you can change these points, okay? I have to check how it can be done here because I know how it can be done in ArcGIS. Okay, so maybe we can do it later because right now I can't remember how can we do that. But I know how can you do it. So what happens sometimes if you see here, this is not correctly aligned with what we were intending. We needed to cover the area that this civilization is covering, but this is also covering ocean part also. Okay, so we need to realign this. So we need some post processing, okay? So that requires post processing and correction. So these error needs to be corrected. So maybe in the next class I'll tell you how can we correct this. Right now I can't remember those steps, but it was something related to this one. But still in ArcGIS I can show you, but here I can't remember. So before that, we can see what are the different types of errors. So these are the types. Now I have some questions related to this. So what is an undershoot? A line that is misplaced, a line that doesn't reach a junction, a line that's okay. So correct. A line that doesn't reach a junction point. Now the next is in digitizing. An overshoot means okay. So correct. A line a line continues beyond its endpoint. Okay. Now next question. Here we have some options. Options are A digitizing, B GPS, C remote sensing, D scanning. So drawing lake boundary on a tablet. What is this? Hmm, no one. Uploading lat long points from field using mobile device. What is this? This is B. Somebody answered A, B, C, D. Okay. Now what is this? Using Landsat imagery for forest cover mapping. What is the method? Yes. This is remote sensing. Now converting hard copy soil map to digital format. So this is D. This is scanning and then uh, drawing lake boundaries, digitizing. Okay. So for drawing the lake boundary, what you are doing? You are scanning. So you are digitizing the map and then uh, making what? A polygon vector file. Okay. So that is digitizing. Okay. So this will be A, B, and this is scanning. Okay. So this is D. So these things we already know. GIS stores simplified representation of called a data model. There are different layers, and their representation can be discrete data. So discrete data can be shown by what? Vector vector files, vector data, and continuous data can be shown by raster data. Okay, so now the next question is, in GIS, the process of simplifying infinite real world complexity into usable form is called what? Rasterization, data modeling, topology creation, square tree processing. So this is data modeling. Okay, so we are simplifying real world complexity using a model. Okay. Now, next question, sorry, lakes, roads, and buildings are examples of what data? Continuous or discrete data? Okay, correct. Discrete data. Now, discrete data has what? Clearly defined entities. So they are very easy to locate, and they are also called as thematic, categorical, or discontinuous data. And some examples are lakes, roads, and buildings, and they are mostly represented by vector data. Now, which of this is continuous data? Village boundary, road network, elevation, or land parcel? Okay, so it's elevation. Now we'll move on to continuous data. So phenomena where every location has a measurable value. So that particular uh, type of data is continuous data. This is also called as field, non-discrete or surface data. And some examples are temperature map, elevation model, rainfall distribution. So these are all called as continuous data, and they are mostly represented by raster data. Now, in the raster data, you cannot represent all the location. What we do is that we define something called as smallest unit of raster data, which is called a pixel. Pixel represent a definite area on the map, and each pixel is going to have one value. Okay, so there is going to be some spatial threshold after which you cannot like go in detail. Okay, so that spatial resolution depends on how the data was required, what was the sensor type. So this spatial resolution needs to be checked whenever you are downloading any data. Okay, so now the next question, which statement about objects in GIS is true? So every they have value at every location. Next, they can have empty space between them. C, they must be stored as raster data. D, they represent gradual changes. So which statement is correct? So Smita Koyal is saying A. Now, which is correct? Objects are discrete features, okay? So there can be space between them. So for example, if if you see here, so if you see here, these point features, they have space in between them. But these are like objects. These are settlements there. So these objects are basically discrete features. So there can be space in between them. Okay. And all the other features are the feature of a raster or continuous data set. Okay, or field as we say. So the continuous data sets are also called as fields. Okay, so if we see the difference between the objects and the fields, you can see objects are discrete but fields are continuous, and objects can have space between them but fields have value everywhere. And you can see the examples are houses, river, points, and they are represented by these vector points, line, and polygons. And these are represented by raster grids or TINs. Okay, so this is the difference between object and field. Now the next question is, a field-based ontology assumes A, the world is empty except for features. B, value exists everywhere in space. C, yeah, so objects are represented by. So Poyal is asking a question that objects are related to vector data and fields are related to raster. Yes, it is correct. So basically, these objects are represented by the vector data. So which are points, lines, or polygons. Okay. But the fields, they are represented by raster data like raster grids, or you can also represent it by triangular irregular networks, so which is called as strings. Okay, so fields have value everywhere. Okay, so that is why they can be represented by raster data set. But objects, they are discrete, so they can be represented by vector data sets. Okay, so you are right, they are related with objects are related with vector and fields are related with rasters. Now, okay, so Lakshmi, Shweta, and Koyal, they have answered. So for a field-based ontology, value is going to exist everywhere, so that is why they can be represented by raster. Okay, and these other features are for object-based ontology. Okay, so that is why this is the answer. So this we know, and I think this is very clear because like mostly all of you have answered all the questions. So right now I'm sure that you know which features are vector data models, which can be represented by vector data model which can be represented by raster data models. Now we'll move on. So we know, and we also have like using digitization, we have made also vector data files. So we made point shape file, we made line shape file, we also made polygon shape file. So now if we look in detail about the polygon storage, there are uh, different types through which the polygon storage can be done. So first is non-topological structure type 1. So in this every polygon is stored as sequence of coordinates, and the common boundary is coded twice for two adjacent polygons. So suppose I'll use a pen. Okay, so suppose there is this feature lake here, and then there is some feature here. Okay, so here what happens, every polygon, so this is one closed polygon and this is another closed polygon. So in this type what will happen, every polygon will be stored as a sequence of coordinates. So as a sequence of coordinate it will be stored. So since every polygon is getting stored, the common boundary between these two polygons will be coded twice. Okay. So this is called as type 1 non-topological structure. In type 2 what happens? This is not stored as polygon, this is stored as arc. Okay. So every arc is stored, and since only the arc is stored, then what will happen? It will store this arc first, then this arc, and then this arc. Okay. So there is not going to be like the common boundary will be not coded twice in this topological structure. Okay, so this type of storage is more efficient, and the shared boundary is only stored once, and this is used in most of the GIS packages. Okay, so now if you see here, this is the original map. Okay, and this is the map that we have created. So you can see, for this we will manually trace this particular map, and these are the points suppose you are taking, then this is going to be stored. Okay, so how a point will be stored as single xy, so let long location, single point. A line will be stored like a string. So maybe, so suppose this x is a point. So it is stored as x comma y. Okay. And an ID is assigned. So this number you can think of it as an ID. Now line 23. Line 23 is this one. You can see this 23. So this is stored as a string. So this is sequence of coordinates that we have. Okay. Now, for the polygon, so there are two polygons, 63 and 64. So 63 can make a closed polygon, closed loop, and 64 is stored as like removing the shared boundary, how the structure is. Okay, so this is how data structure is stored in the vector data model. Okay. Now there are different operations that you can do like union, intersection, symmetric difference, clip. So these are things that you can do with the vector data. Okay. Now I have a question. The question is, the vector data model stores data as first pixel. Okay, so this is very clear. Everybody knows this is point, line, and polygon. Okay, so outline of a country is also polygon. And I don't think these questions are needed now. Now next question is which statement is true? So while you are digitizing, um, you need to know what precision accuracy means. So you have to tell me which of the statement is true. So precision means closeness to the true value. Accuracy means repeatability of the measurement. C. Accuracy means closeness to the true value. D. Precision and accuracy are the same. Okay, so Smita is saying that accuracy means closeness to the true value. So let's see. So it is correct. Now, if you want to understand what is precision, what is accuracy, you can think of this. Okay, so suppose this is the true value. So as you go to this center point, you are getting close to the true value. Okay, so here if you see all uh, the three dots, these are scattered. They are far away from the middle point, center point. So that means they are not even accurate and not even precise. So precise means the measurements that you are doing are within, like they are very close, and accuracy means they are close to the true value. Okay. So suppose in the second case, what is happening? These all three are very close to. Suppose you see this second option and the third option. So in the third, all three of them are very close to each other. So they are very precise. But here they are not very close, but they are close to the middle point. That means they are accurate. But if you want high precision and high accuracy, that means you have to be close to the true value and all your measurements should be close to each other. Okay, this is what precision and accuracy means. Now you have to solve this. Uh, there are two survey teams and they are measuring the same point. Team A is getting 100.1, 100.2, 100 and 100.3, and team B is getting 99, 101.5, 102, 97.5. So which team is precise? Okay. So team A, because their measurements are very close to each other. Okay. Now, if we look at the vector data structure, so there are two common ways of storing. One is called as spaghetti model and second is topological model. Okay. So in spaghetti, what happens? You have to store each feature independently with coordinates, and there is no relationship between the features that we are getting stored. So these are very easy, simple, easy to store and visualize. But what happens? There can be data redundancy, means some features can appear twice, and because there is no topology, so it is harder to analyze. Okay, so there is no relationship between the features, so that means analysis of the structure is going to be harder. Okay. Now there is topological model. So what it does is that it stores geometry and also the relationships. So it use arc node structure. So what happens is that it enables spatial analysis without rechecking coordinates, and this is like more complex because here you also need to store geometry and the relationship between different geometries. Okay, so this is kind of more complex. So the next question is, which vector storage method ignores spatial relationship between features? Topological, raster, spaghetti, and network. So we already have seen spaghetti model. It records all the features independently and there is no relationship stored. So that is why it is going to be spaghetti model. Now the next question is, in the topological vector model, adjacency refers to what? A. Two features having the same attribute value. B. Features that share a common boundary. C. Features stored in the same file. D. Same coordinate system. So what that refers? Okay, so most of you are saying features that share a common boundary. So in topological model, what we have, we also save spatial relationship, and in this adjacency means there is some a common boundary between the two features. So this is what this means. Containment means there is one feature within another feature. Okay. Now, so if you are storing any attribute data, you can also make a table, and attribute table is very useful, and it can also stored store value of each. Like suppose you make, so suppose you make, like for this feature you added one, two, three, four settlements or points, right? What you can do is that you can open the attribute table. So right now it was like while we were creating this feature, if you remember, it was asking for what? It was asking for ID. So you have given ID 1, 2, 3, 4. Now you know what was 1. 1 was suppose Harappa, 2 was Mehergarh. So you can also add a table and write the name of the cities in the ID and also add some other feature like what was the uh, area of this particular village, or like some other feature like population or any other thing that you want as a value, you can add it. Okay, so this is what attribute table is, and if you want to check any attribute table, you have to right click and then open attribute table. Okay, so you can add features or add extend this table also. So now we also have raster data model, but since we don't have much time, so what we can do, we can start this raster data model in the next session. And in the next session, I'll also uh, tell you how we can do analyze digital elevation data in ArcGIS and QGIS. So this will be the hands-on session for the next class. Okay. So till now, if anybody has any questions, they can ask. Any doubts or anything, can ask me. Anyone? Any questions? Okay, so you can email me um, after this class, maybe. Okay, and then we can discuss that because that is not related to this particular session. Okay, so you can just email me. You have my email ID, right? I can just write in the chat box and you can. Okay. Other than that, anything related to this session, if there is something we can discuss. If not, then we can end this session. So thank you everyone, and I was very happy that you all were answering, and like almost 99% of the time you were correct. So thank you for making this engaging, and I'll recommend you to download QGIS or ArcGIS and do these steps on your own, because by doing that you are going to like learn more as compared to just watching me do it. So if I'm doing that, it is going to like I'm just revising what I already know. But if you try, it will be like very useful for you for future also. Okay. So thank you all and happy learning. Bye bye.